Hello, this is Stats, Math 260. We're looking over review 2. Now, we've already covered this review in class, but just in case if you weren't there or you want to go back and see the explanation already, I'm going to just walk you through what we did and how we got everything. So on this first problem, we have we're supposed to make a tree diagram and then give the sample space. A sample space is a list of all possible outcomes. That's what's right here. The tree diagram is constructed because it says there's a 1, a 5, a 10, and a 20. You pull them out without replacement. So you get to pull 2 bills out. So there's a 1, a 5, a 10, and a 20, only one of each. So all the possible outcomes for that first try is a 1, a 5, a 10, or a 20. That's each one of those branches, 4 branches. Off of the branch, if I pull a 1 out, there's not a 1 left inside anymore. So there's a 5, a 10, and a 20. So there's 3 branches off of that. If I pull a 5 out, there's a 1, a 10, and a 20. If I pull a 10 out, there's a 1, a 5, and a 20. And if I pull a 20 out, there's a 1, a 5, and a 10. And so at the end of each one of these branches, 1 and 5, that's the sample space. 1 and 10, 1 and 20. So that's all of the possibilities if you pull a $1 bill first. If you pull a 5 first, we could get a 5 and a 1, a 5 and a 10, or a 5 and a 20. If I pull a 10 first, I could get a 10-1, 10-5, 10-20. Or if I pull a 20 first, I could get a 21, 25, 20, 10. All right. Next one, it says make a tree diagram. Oh, I'm using C3PO here as an edge for the paper, so I know where the paper is on the setup that I have here for the video. So we have girls and boys. The first child could be a girl or a boy. You're going to have 3 children. So then the second one could be a girl or boy, or a girl and a boy. So this is the scenario: girl, 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 boy, boy, girl, boy, boy. So if there were only 2 kids, we'd be done. There's 3 kids though, so that's another branch. So it could go girl, 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 boy, girl, boy, girl, girl, boy, boy. So each one of these n branches, we do another 2, girl, boy, girl, boy, girl, boy, all the way down. And then we just follow the branch and put down the combination. So girl, 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 there it is. Girl, girl, boy, girl, boy, girl, girl, boy, 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 girl, boy, or no, I'm sorry, boy, girl, girl, boy, girl, boy, 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 girl, and boy, boy, boy. All right. The next part, number 3, is really just vocabulary. So combination, when you're using combinations, order doesn't matter. Permutations, order does matter. Classical probability, that's what should happen mathematically. Empirical means you ran an experiment. Subjective is an educated guess. And I mean, there's math involved in it too. You're not just picking numbers out of the air. Independent events are one outcome has no effect on the other outcome. That could be like flipping a coin, tossing a die. Mutually exclusive events, those are different outcomes of like the same event that can't happen simultaneously. So if I roll a die, if I get an even, it can't be an odd. So even and odd would be mutually exclusive. Fundamental counting rule just says you multiply how many possibilities there are for each thing to find out the total amount of outcomes. Sample space is a list of all outcomes. Discrete probability is a finite number of possible outcomes. And a random variable is a variable whose values are determined and defined well. All right, so what do I need for the criteria for a binomial distribution? SIPY, remember SIPY, S-I-P-Y, set number of trials, independent, probability remains constant, and it's a yes-no question. All right, next page. We had to find all of these different probabilities. So the probability that you pick a blue sweater out of these possible sweaters, well, there's 23 possible, 12, 5, 2, and 4 detailed on the top there. So 23 total, 2 are blue, so 2 divided by 23 is 0.08695. And then we move it 2 decimal places to the right to put it as a percent. So 87.7%. Not white, so we just rounded up everything that was not white. And that was 5 plus 2 plus 4. That was the 11 23rds, 47.83%. Red or yellow, or means add, so we just add up the red and the yellow sweaters. That's 9 23rds. Or you could do it as an or problem, meaning 5 23rds plus 4 23rds. It would still be 9 23rds. Same answer. 4 cards are drawn from a deck without replacement. So without replacement means I'm pulling cards and not replacing them and reshuffling. So 13 out of 52 are spades, but then you got to pretend like you pulled a spade. So now there's only 12 left and only 51 cards left. And you pretend you pulled another one. 11 left and 50 cards left. And you pulled another one, 10 left and 49 cards left. And so on the top, 17,160. On the bottom, 6.497 million. We divide, not a very likely scenario, 0.26%. So the chances that you would get all clubs if you just dealt 4 cards is less than 1%. With replacement just means you put them back in the deck. They wanted the same thing, 4 cards with replacement. So 13 50 seconds, you put it back in, so shuffle it, so it's 13 50 seconds again. And so it's slightly better with a replacement, but not tons. It's 0.3 and 0.4 roughly. 3 cards are drawn, so not 4 anymore. 3 cards are drawn with replacement, so they're putting them back in, getting all red cards. So that's really just 1/2 times 1/2 times 1/2. That's a likely, 12.5%. It's much better than those, which were both less than 1%. Okie dokie. Okie dokie. Number 9. If you have to create a committee, 9 women and 8 men, how many ways can 4 women and 3 men be chosen? So it's a committee. That's important that you understand. Committee means order does not matter. It doesn't matter if you're picked first, second, third, or fourth. You're just on the committee. So the order doesn't matter at all. So 9 choose 4. We do that combination. If you did it by hand, it would look like this. If you did it on your calculator, you just do 9 and then combination button and then 4 and then hit enter. It's 126. And 8 choose 3 is 56. So you multiply those two, there's 7,056 ways. So we actually used from the first page the fundamental counting rule, which says, fundamental counting rule says we just multiply everything. All right. Which is what we did. We multiplied the 2 scenarios. Same thing for this. A little tougher, though. You had to create a golf group of 4. There's 5 women, 12 men. So there have to be at least 3 women, which means 3 women and 1 man, or all 4 women. That would be okay. So the or means add. We're going to actually add up those. So how many ways can I pick 4 women from 5? There's actually 5 ways to do that. Again, you put in your calculator, 5 choose 4, that's fine. And then 5 choose 3 and 12 choose 1. So 12 choose 1 is 12 ways. You can pick 1 man from 12 men. And there's actually 10 ways to pick 3 women from 5 women. And so that's 120 possibilities there, plus those 5 combinations that we get with all women. And so that's 125 total. That's a pretty tough problem. License plates, 4 letters, 3 numbers. That's supposed to be by, not B. How many plates are possible if no letter or digit may be repeated? Okay, so no repeats. So 26 letters in the alphabet times 25, because we don't get to repeat, times 24, times 23. And then 10 times 9 times 8, because you don't get to repeat. Now, why 10? The question comes up because 0 counts as a number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 distinct symbols for our numbers. There's a lot there, 258,336,000. How many distinct outfits can be made from 4 colored shirts, 3 colored pants, 2 colors of shoes? So 4 times 3 times 2 is 24. You're picking 3 senators from 15, so it's a combination. Again, a combination. Order doesn't matter. And so 15 choose 3 is 455. How many ways can a president, vice president, and treasurer be chosen from 15 students? So that's 15 choose 3. But now because it's president, vice president, and treasurer, order does matter. So that's 15 choose 3 is 2,730 ways to do that. 15 was 62% of the people have type O blood, so probability of type O is 62%. Probability not type O is 38%. They want to know, find the probability at least one of them has type O. So what you do is, look, I did a picture of the sample space here. 0, 1, 2, 3, 4, 5, 6, 7, 8. And so if I say at least one, that means 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. So we could do a combination of all those and add them all up, but that would be a nightmare. We don't want to do that. So instead, find the probability of none, the no type O, and then subtract it from 1, and that's what will be left. So when we do that, it's a combination of 8 people chosen 0 at a time, 0.62 to the 0 power, 0.38 to the 8th power, and so not a very likely event, 0.00043, and then we do 1 minus that, so 99.96% chance. Same thing with this, if 62 people, this time we want to know, find the probability at least one of them does not have type O. So that's the exact opposite of what we did there. So it's 8, choose 0, but this time the 0.38 comes first to the 0 power, and 0.62 to the 8th power. That's even, well, that's more likely than that, but it's still really small. 2% chance of that happening. So 1 minus the 2%, there's a 78% chance of that. 17 and 18, skip, don't worry about those. They're not going to be on the test. Page 19 then looks like this. We've got, or not page 19, page 5 on the review, number 19. So we fill in the 36, 67, 56. We add those down and we add them across, 65, 39, 55. And then if I add this way and add that way, I should get 159 either way. And now let's see, the probability the TV was from factory Y. So we look at TVs from factory Y. There's 32 out of 159, 20% chance. Probability it's a TV or a speaker. So we just look at TVs, 65, speakers, 55. So 65 159ths plus 55 159ths is equal to the 120 over 159, 75.4% chance of that. Find the probability it's a stereo given it was in factory Y. So there's 2 ways to do this. The easier way is to reset the sample space. So the stereo given Y means, okay, I know it's from factory Y. I know it's from here. And so if I know it's from here, that means it's, and now the chances it's a stereo from there, 20 stereos out of 67. So it's just 20 67s. So that's called resetting the sample space, if you do it that way. We have the luxury of having the raw data, so we can reset the sample space. We could also do it mathematically, where you do the probability of both occurring, that's 20 159ths, divided by the probability of just Y, which is 67 59ths, and then the 159s kind of cancel off, and you still end up with 20 67ths. All right. Probability y, given it's a stereo. So again, we reset the sample space. Given it's a stereo, that's this row. That's 39 total. And stereos are 20 out of 39. So 51.28%. Probability, it's just the TV. That's easy peasy. So you just add up. You'll just look at the TVs. 65 over 159, 40.88%. And then the last one was tough. It's find the probability a randomly selected item is a TV or it is from factory X. Well, that means TV or from factory X. There's 65 TVs out of 159. Factory X is 36 out of 159. But we counted the TVs from factory X twice. That was in the 65 count, and that was also in the 36 count. So we have to subtract that off. So the 18 159s get subtracted off because it was in both of those numbers. So 83 159s, 52.2%. And then the last page, they always have to add up to one total. So you add up all of those probabilities and subtract it from one. So that's 0.23 was the missing, or 23%. To find the mean, the expected amount, you would take each one of the values right here, the 0, 1, 2, 3, 4, 5, 6, 7, times the probabilities. So that's what happened there, and then add them all together. So it's 4.19. So the mean is 4.19. Then to find the variance, that's a little tougher. You're going to square each one of those values, 0, 1, 2, 3, 4, 5, 6, 7, 8, or 7, sorry, 7. And then multiply it by the probabilities just like we did before. So here's the actual work of that all happening. And then subtract the mean squared. Don't forget that part. That part gets overlooked a lot, and that's really kind of important. So 20.85 minus 17.5561 is 3.29. And then the last, find the standard deviation, easy peasy. You take the square root of the 3.29, and that's 1.81. All right, 21, determine that it is a binomial distribution. So SIPI, set number, there is a set number, 28. Independent, the word random should be in there. It'll be in there in the test. The random word random will be there. Probability remains constant at 70%. And yes, no question, yep, study or not study. And so this first one says exactly 20 students. So that's a combination of 28 students choose 20, 70% chance that they're going to study time up to the 20th power, and then 30% chance that they're not going to study. Those should always add up to 1. The 0.7 and the 0.3 adds up to 1. And then this 20 plus 8 should always add up to the 28 total, or how many total students there were. So 20 to 8. And then you put that into the calculator, put that into the calculator, that into the calculator. Oh, really big numbers. So we end up with 0.1627 or 16.27% chance. The next one, find the mean. That's actually quite easy. There's a 70% chance they're going to study. 28 students, that means the expected amount, or the mean, would just be 70% of 28, about 20, 19.6. Variance, also kind of easy to calculate in the terms of a binomial distribution. You just take n, which was 28, probability is 0.7, and then q is the probability of not studying, 0.3. You just multiply those three, and that's your variance, 5.88. And then standard deviation is always the square root of the variance, so just take the square root of 5.88. And that is it for the review.